with Ardino for everyone.
I thought there were prizes.
Welcome to the workshop. Please be reminded that this is an extremely compressed workshop because we are trying to put this into one day, as most workshops take up 2 or 3 days. So I might be a bit fast. So let's start. Let's start with basic electronics. So this is a circuit. Oh wait, that's a circuit. An electronic circuit is a complete course of conductors through which a current can travel. Circuits provide a path for current to flow. To be a circuit, this path must start and end at the same point. In other words, a circuit must form a loop. The difference between a closed and an open circuit is that the closed circuit completes the entire loop, while the open circuit stops halfway. Now, there are two different types of circuits. There's series and parallel. When you look at the series circuit, as you can see, there's only one path. And if that path were to be cut somewhere in the middle, the circuit will no longer be closed, and your entire electronic system will not work. A parallel circuit, on the other hand, has multiple paths leading back to the same point. If one of the paths is broken, the circuit will still be closed, meaning electricity will still flow through. So let's continue on to polarity. Some devices have polarity, meaning there is only one way to wire and attach them. If one of the wires gets switched, the device could break. I have seen many instances where people or students or even myself, I have reversed wires. And you will notice whether or not you've reversed these wires because you will notice something within your machine, your electronics, to heat up really, really fast. And this is a huge amount of heat and it will break your electronics. So if you've heard the term in scientific movies, reverse the polarity and you break everything, that is true. So examples of devices with polarity are diodes like the LEDs, and we have transistors, integrated circuits, and any power supply, which are batteries. There is always an indication whether or not something has a polarity. One of the pins could be longer, or the device itself could have an indication. Like how batteries always have a plus and a minus on it. Although there are also some devices that do not have polarity, so the electricity can flow either direction. So you won't have any worries about plugging this in the wrong way. Examples of this are resistors, switches, and potentiometers. The number one rule in polarity is that you should never connect the positive directly to the negatives, or else you'll break your entire system, your circuit, and practically everything else that's connected to it. So let's move on to the breadboard. I know I'm going a bit quick, but we'll have an exercise later, so don't worry. The breadboard. Every circuit has to start somewhere. When you're still testing out your circuits, it is best to use a breadboard. On the right is a diagram of how the holes of the breadboard are connected. So, usually when you look into machines, you find this green little circuit inside, or any type of robot. You usually find this green board inside, this green circuit board inside, where you can't even see where the wires are going anymore because they're actually inside the board itself. Do you guys know that thing, or are you just getting confused? Okay, probably getting confused. Anyhow, so let's move on to resistors. As I said earlier, resistors are one of the things that do not have a polarity. And as you can see on the side, there are resistors with many different colors and bands. Each of those colors has a specific meaning, telling us what resistance the resistor is on. So resistors are electronic components which have a specific electrical resistance. The resistor's resistance limits the flow of electrons or power through a circuit. Some devices need resistors to lower the amount of power that will go through it because it can't handle